Let's talk about conic sections, and we're going to go all over the place on this one. So here's a right triangle, and its side lengths are 4.12, 2.82, and 5. And then we can do another right triangle over here, and its side lengths are 2.52, 4.31, and 5. And if we keep doing a lot more of these, and we trace out this vertex, eventually we're going to make a circle. In fact, I'll show you the circle being traced out. So as we move this triangle around, you can see that circle being traced out. And then we can also go into these other quadrants and finish up the circle down here. If I look at this right triangle, and I call this A, this B, and this C, we know that a squared plus b squared equals c squared. But this a is equal to the x value of our point, so we can call that x squared. This b is equal to the y value of our point, so we can call that y squared. And this c is equal to our radius, so we can call that r squared. So this is one equation of a circle on a Cartesian plane. X squared plus y squared equals r squared. So we're going to plug in 5 for r, and then now let's increase that 5. As that 5 in the equation increases, so does the size of our circle, and as it decreases, so does the size of our circle. They're directly connected. And now if inside of parentheses we put minus an h and a k, that enables us to move the circle from left to right and up and down. If we plug in 0 for h and k, the circle is not going to move yet. But watch what happens as our k grows. As we subtract larger numbers, the circle goes up, and if we add a number, it's going to go down. We can also go left and right by increasing the h that's subtracted from the x. Or by adding, we go to the left. And we can do a combination of the two. And then we can also change the r, so we can do really anything we want with our circle. So now we can divide everything by that r value. With this right-hand piece, we can change to 1. Now what's happening is these two r's down here, they are now the radius of our circle. The cool thing about separating it into two separate r's is now if I change just this one radius and I shrink it down, it's now going to get skinnier. This is the radius in the x direction, and this would be the radius in the y direction. I can make it larger if I want. And notice how it's stretching it taller. So now with these two numbers, we can now change the shape of it in this direction as well. And we can still change our k to move it up, and we can still change our h to make it move left and right. And this is the equation of an ellipse. Now, if we really want to go crazy, we can shrink this so much that it goes negative. And when it's negative, now we have a hyperbola. And this hyperbola can also move up or down and left and right. By changing these two radiuses, we can also change the shape of it. And if we make the other one the negative, then we spin the direction that they're at. But same thing, we can still move it left and right, up and down, and we can change the shape of it. And so when one of these is positive and one of them is negative, that creates a hyperbola, which is two curves. Last thing we can do is get rid of one of the squared values and rewrite it as just a y. We can make it so only the x is getting squared. Now as we work on this leading coefficient, we can make it taller or fatter, or we can also make it negative and turn it upside down. And same thing, we can still move it left and right and up and down. If we switch it and make the y the squared value and the x not, then we get the parabola going this other direction. Hope you guys enjoyed this introduction to conic sections. Comment on what you'd like me to talk about next. I'll talk to you soon.